Algebra 2, this is lesson 99, absolute value inequalities, disjunctions, and conjunctions. You can see at the top of your notes here a couple of examples of what we will be looking at for graphs today. This is on a number line, and we are going to end up shading either in between some numbers like a sandwich graph, or we're going to shade the outsides, which I call the wing graph. You're going to see that the inequalities themselves are almost identical. It's just one of them is less than and one of them is a greater than. So we'll go through how you would break that down and know which way to graph. Starting with your note star 1, the first thing I'm going to do is have to get that inequality, or excuse me, that absolute value by itself. Okay, my goal is to get this absolute x all by itself. So I need to subtract the 3 to the other side. And that's going to give me absolute value of x is less than or equal to 2. Doesn't flip a sign or anything. All I did is subtract something over. Okay, now I'm going to break that into two equations. Whenever we have an absolute value with an inequality, it breaks down into two equations. The first equation, you just bring it straight down without the absolute values. So x is less than or equal to 2. The second equation, we still have the x, but we flip our sign and we change to a -2 for our answer. Okay, and then we're going to graph that. So it looks like I need to have graphing from a -2 to a +2. When I do my number line, I need to include a -2 and I need to include a +2. Now, if you want to, you can go ahead and graph in between there as well. The -1, 0, and +1. I'm going to start by looking at the first one, x is less than or equal to 2, and that is over here at the 2. It's a closed circle because it says the equal bar, and it's less than, so I know that it's going to be heading this direction. Okay, and then I have the second equation where it's at the -2, it's also a closed circle, and it's greater than, so I know it's heading this direction. Now what we do is we combine those two arrows into one sandwich in the middle. So it's going to look like that. All right, let's try number 2. First thing again is we want to make sure the absolute value x is by itself. So now I am going to divide 2 to the other side. And I get the absolute value of x is greater than or equal to 4. I'm going to break it into two statements. The first one is just as I see it, x is greater than or equal to 4. The second one, I flip my sign in the middle, flip my symbol, and I also change to a negative. So I'm going to have my number line go from -4 to +4. Okay, and they are going to be closed circles. The reason for that, because they have the equal bar. So a closed circle on each of those. This first one is dealing with the +4 and it says it's greater than, so it's going to go out to the right. And the second one says it's less than, so it's going out to the left. This one ends up being a wings scenario. All right, we're going to have two other scenarios that can happen. So now let's focus in on question 3. We have some steps to take care of. First of all, we need to add the 3 to the other side. So I get negative absolute x is less than or equal to 2. And then the next thing is I have to get rid of the negative. So absolute value of x is greater than or equal to -2. I want you to think about this before we try graphing it. I want you to think about it theoretically. it's telling us if I put a number into this absolute value, and I could put in the number 10, I could put in the number -10, -6, it always gets absolute valued. In other words, it becomes positive. And a positive number is always going to be larger than a negative. Okay, so therefore, no matter what number I put in for x, it will always be greater than or equal to -2. And so that means when I go to graph it on my number line, it doesn't even matter where on this number line that I graph, it can be any real number. So I just draw a line showing that it's all real numbers as my solution. Every once in a while you'll get a somewhat tricky question like that from Saxon. Okay, now I'm going to go to question 4, which is also a little tricky. Starting off by noticing there's a -2 being multiplied, so I need to divide that to the other side. So I have absolute value of x. Dividing -2 means I flip my sign, and I have 6 divided by -2, and that would become -3. So once again, I'm going to approach this one theoretically. What number can I plug in for x that is going to be less than or equal to -3? Well, every number we plug in here becomes absolute valued, and it ends up becoming a positive integer when we're done, or a positive number when we're done. So that means that this is never going to happen. It's not true that I can plug in a number and it would end up being less than or equal to -3. It's always going to end up being greater than. So when that happens, I have to put no solution. Okay, there's no solution because there's not going to be a time where you can have an absolute value less than or equal to a negative value. All right, now we're going to try the practice question from your textbook on page 411. It starts off with a negative absolute value x plus 3 is less than a -2. And by the way, it gives us our domain of integers, which just means no fractions, no decimals, please. So let's work on that inequality by first subtracting the 3 over. I have negative absolute x is less than -5. And then I need to get rid of the negative out in front, so I multiply a negative to both sides. When I do that, it flips my symbol in the middle and changes it to a greater than symbol, and then -5 becomes +5. So I have the absolute value of x is greater than 5. Well, this shouldn't have any kind of no solution to it because we have a positive number on each side. So instead, I'm going to break that into my 2 solutions. The first one is always the way you see it right now. Just take away the absolute value symbols. Okay. The second one is where we flip the symbol and change it to a negative or an opposite on the answer. And then I'm going to go ahead and draw my number line. I note that it's from a -5, +5 perspective. And then that first one is greater than 5, which means I'm going to have an open circle heading off to the greater than side. The second one is a less than, -5, so I have an open circle heading toward the less than numbers. However, if you do that and stop there, that's not going to be the correct answer because we are only working with integers. So that means that we can only have whole numbers, no decimals or fractions. But it's important to know we had open circles at 5. So what that means is when I go back, I can't actually put a closed circle on the -5 or +5. Okay, so I'm going to go back here and get rid of that And instead, think of it as if it's an open circle at -5, the next number is the first time I get a closed circle. That would be at -6. Same with this side, it would be +6 and +7. And then we need to show that that continues. So I make an arrow that's moving us that direction. Okay? So it's a closed circle at the -6 on down, closed circle at 6 on up, but it's only at the integers that we put our dots. All right, and then lesson 99 is on delta math for homework. Good luck.